Utilizing Pulsed Eddy Current (PC) techniques on small-diameter insulated pipes. Good afternoon, everyone. Today we'll explore a significant topic in non-destructive testing, using Pulsed Eddy Current technology on small-diameter insulated pipes. I am excited to share with you the benefits, challenges, and alternatives of using Pulsed Eddy Current on these small pipes, along with insights from recent experiments. Small-diameter pipes, specifically those ranging from a nominal pipe size, NPS 1 to 3, are common in various industries. These pipes often face issues such as corrosion under insulation and flow-accelerated corrosion, just like their larger counterparts. However, inspecting these small pipes poses unique challenges due to their highly curved surfaces. Despite these challenges, Pulsed eddy current can be effectively used on small pipes. The technology allows for the detection of defects even when they are located on the opposite side of the pipe, thanks to the way the pulsed eddy current response or wraps around the pipe. One significant advantage of using pulsed eddy current is the speed of inspection. A larger footprint can screen the entire circumference of smaller pipes more quickly, making the process efficient. With sufficient insulation thickness, pulsed eddy current can provide comprehensive coverage of the pipe, ensuring that even large defects are detected. However, there are also some drawbacks to consider. A larger footprint, while beneficial for detecting large defects, can sometimes lead to the detection of fewer smaller defects. This is because the larger area averages out the signals, potentially missing minor issues. Additionally, the tolerance to liftoff, which is the distance between the probe and the pipe surface due to insulation thickness, is limited. This means that while pulsed eddy current can work effectively, there are specific ranges of liftoff that must be maintained for optimal detection. Several alternative techniques are available for inspecting small-diameter pipes. Radiography uses X-rays to inspect the internal structure of the pipes. While effective, it can be time-consuming and requires significant safety precautions. Ultrasonic testing uses high-frequency sound waves to detect defects. It is highly accurate but can be challenging to use on small curved surfaces without specialized probes. Magnetic flux leakage detects corrosion and pitting by using a magnetic field. It is effective for larger areas but may not be as efficient on smaller, highly curved pipes. To understand the effectiveness of pulsed eddy current on small insulated pipes, a series of experiments was conducted on a nominal pipe size, NPS 2 pipes with varying insulation thicknesses. Each pipe had 2 simulated defects, while observing how pulsed eddy current responded to these defects. When scanning directly over the defects, the detection capabilities decreased as the liftoff increased, because the defects filled a smaller portion of the averaging area. Interestingly, when scanning 180 degrees from the opposite side of the defects, detection capabilities increased with liftoff up to a certain point. This was because the probe's footprint began to wrap around the pipe, allowing it to see defects on the far side. Through these experiments, it was noted that the optimal conditions for detecting large flaws in what we call the small pipe regime. For instance, on a nominal pipe size, NPS 1 pipe, the optimal liftoff range is between 25 to 38 mm with a small probe. On a nominal pipe size, NPS 2 pipe, this range shifts to 51 to 76 mm with a medium probe. In conclusion, while inspecting small-diameter insulated pipes presents challenges, using pulsed eddy current technology offers significant advantages. It allows for efficient and comprehensive detection of defects, making it a valuable tool in maintaining the integrity of these critical components. Despite some limitations, pulsed eddy current's ability to provide fast and effective inspections makes it a preferred choice in many scenarios. Thank you for your attention. I hope you found this discussion insightful. I look forward to your questions and further discussions on this topic.